Hi everyone, my name is Tiago Dias. I'm a developer at Diconium. We are recruiting if you are interested. So, today I will talk about Vue.js, how to handle the state with Vuex. So, who have heard about Vuex? Okay, good. And those who have worked with Vuex? Okay, great. So, Vuex. What is this? What is this word? So, Vuex, it's, as Filipa mentioned earlier, it's a concept, it's based on a Flux concept that the data flows one way only. For instance, as we see here, it's the view, it dispatch actions to the dispatch actions, the actions mutate the state, and the state re-renders the view. Basically, it's this. So, it helps to manage the application state, easy. It enables a single source of truth, so every components know the state at one point in time, it's the truth, so they read from it and they write to it, and it's only truth to them, so they always know how the application state is. But it's not a silver bullet. So imagine that you have a little project with like 2-3 components. Vuex may introduce a little boilerplate, a little complexity, that it's not ideal to that case. So you should not implement it because it's good. You should implement it if it's needed. So it's on this. Okay. So before we start talking about Vuex, let's talk about state. For instance, state per component. As we see here, we have a Vue instance, a simple one, that we have the self-contained state of this component. We have a template, and then we have actions, self-contained actions that deal with the self-contained state of this. In this case, it's a root component because it's an instance, but it's self-contained in here. So it's easy to manage because we always know which state we have at the moment. But what if we need to share some state with another component? Or a method of one component should be able to update the state of another component? How we deal with this? To do that, we have props, as Filipa told. Props enables communication downwards, so from the parent to its child, nested components. So we can see here, we have a parent component, a simple one, with data. It's a simple object with some message as a property. And then we have a template. The template is a child component, which will receive a message prop, and then the message prop will have some message passed by to the child. And here is our child component. It receives a props with message, it's the name of the prop, and then it can be used down here at the template, as we can see, a vtext message. So, using props, we can communicate the state from the parent to its child. A downward communication. But what if you want to go upwards? So the child can communicate with the parents, with his parent. We can use events. We have not only, but the two main ways to deal with this is using a global event bus. It's nothing more than a dedicated Vue instance. It emits events to the bus. Then the components that are listening to that bus, the messages that they want to deal with, they will listen on them, and then on a callback we'll do something with the payload that the event has. So for instance, we have a bus, it's a new Vue instance, no template, no styles, no state, no nothing. And then for instance, on this Vue instance, on this method, on the select method, we will emit an event with some payload. On another component, in this case it's another Vue instance, usually on the created method, the created lifecycle, we can listen on that event and do something with the payload that the event has. This is one way to do it. The other way, it's custom events. Custom events are triggered from the child to its parent, and then the parent handles the event. So the global event bus, it's a global bus that everyone can listen to. Custom events are from its child to its parents, and then enables data flow upwards. So, in this case, this is a template of our root instance. We have two button counters that are two components, and then we have the v-on increment, where increment is the name of the custom event that we are passing from the child to its parent. And when that event occurs, the parent will fire the increment total method on its component. So, for example, in here we have a view component, button counter, and then on the template section we can see that we have a button that on click it will trigger this increment counter method down here at the method section. Then the increment counter will increment its own counter, own state, and then we'll emit an event named increment. As we talked earlier, we can see that the increment is the name of the custom event, so the parent will receive this event. Right here it's emitted, it will receive it, and it will trigger the increment total, and the increment total will then increment the total of its parent. So the child can now communicate with its parent and change the state through custom events. So these are the two main ways to deal with this kind of, not difficulty, but when we want to communicate state from the child to its parents, these are the two main, usually how people deal with it. So, when we have a lot of components, sorry, you want to?
What is the source of two there? Can
Sorry?
you go back?
This we are not talking about Vuex. Yes, this component has its state. That component has its state. So there is no singular point of truth. So when we have a lot of components, that can be daunting. Emitting events and listening to events and callbacks in here and callbacks in that. Vuex is here to rescue us from this hell. It has like 4 layers: state, actions, mutations, and getters. And we can see them right here. For instance, the view components, it's our components. Then they will dispatch an action. The actions are asynchronous. They can do API calls or a request for a user's camera on the browser. Then when that callback is resolved, then it can commit a mutation to the state, and then the state will be mutated by the mutations, and then all the components that are listening to this state will be re-rendered instantaneously. So this is, as we saw before, it's one way only. So component, action, action, mutation, mutation, state, state, component. So let's talk about the store. This is a basic store, a basic one. It has a state, action, mutation, and getters, as we saw previously. A store, it's a state. It has an action. For instance, it only has one action, it's update count. It has the mutations. With one mutation, it's increment. And a getter, it's only one getter, it's higher than 10. And then when we instantiate our main view instance, we will pass the store just to view know that there is a store in it. So we can start using it. So this is simply the simplest case of a store. This state right here, it's the single point of truth. Everyone is dealing with this state and reading from the state. So the state, it's a simple JavaScript object. It can contain arrays and strings and objects with another objects in it. It can be everything that JavaScript supports. In this case, we only have a count property, which is numeric at this point, with a value of 0. Actions, as I said, it deals with asynchronous code. It's the best place to make API calls, and it's the right way, the right layer to do API calls. Always receive the store context as the first argument, as we can see in there. And it's a layer between components and mutations. As we will see, mutations can be called by components because we don't always want asynchronous code to run, but synchronous code. But usually, we use an action layer between components and mutations just to avoid having asynchronous code trying to mutate the state. And actions are dispatched. That's what they are, and can be dispatched by components or by another actions. We can, like building blocks, an action runs an action, and so on and so forth. So, mutations. Mutations, they are synchronous, always. It's the only acceptable way to deal with the state. So, the actions, the mutations are like the only gate that we can go through to deal with the state. And the mutations are committed. When we want to do some operations over the state, we commit a mutation with or without payload, it depends, and that mutation will deal with it and it will update the state or do whatever it has to do. In this case in here, we have an increment mutation which receives the state as the first argument, always. I forgot to mention it here. And then the payload of that mutation. In this case, for instance, I'm using the payload.counter to update the state.count. So my count property will be updated using that payload object. And for last, getters. The getters are the last part of the flow. They act like computed properties for state. Computed properties, instead of we mutate the state, we use computed properties to deal with it and to filter something or to check if something is true or not. So it's like it's the state, but with computation on it. For instance, in here in this getter, I'm checking if my count property, my count state, it's bigger than 10. So instead of retrieving the state to the component and then the component deal with these type of calculations, I can center it here, and if 10 components, 10 different components, unrelated components want to know if the count at that precise moment is higher than 10, they can use this getter instead of receiving the state and doing the calculations by its own. Like I said, it's the perfect layer to perform calculations over state data and always receive the state as the first argument as well. So we receive the state and do things with the state. So this is the previous example that I used from the button counter, but instead of using a custom event to communicate, I will use my store that I created to deal with this. So it's exactly the same. We have a template section with a button. When the button is clicked, it will increment the counter. The counter will then increment its self-counter, self-contained data, and then it will dispatch an update count. Easy as this. And then I have a show counter that is a computed property from this component that will receive the getters. In this case, it's higher than 10, and it will reevaluate the show of the button if we want to show it or not. If I have another component that needs this type of functionality, I only have to do it. Okay, I will dispatch an update count again, and I will listen to my getter, for instance, or I can retrieve the state count if I want to. It's easier to manage the state this way. So I tried to show you what we are talking about. I will try to show you a little demo. Let's see if I can go there. Okay, so whoop. So this is exactly what we saw before. Okay. So in here we have our mounting point, it's app. We have a paragraph which will write on the screen the total clicks that we have, and 2 button counters. Our component is we have already seen it. It's a button. At click, we will increment the counter, and then it will display the self counter that he has. This is exactly what we have. Just note this in here. I will not dispatch an action because I don't want to do any asynchronous code. I will commit a mutation directly from here. It's possible and only doable if we don't have any asynchronous code to run. We instantiate our store in here, as we saw before. I'm doing some console logs just to see what's happening. And then I have my main view instance with the store in it. And then I have a computed property, total clicks, that we will receive the count directly from the state, not using a getter, because we don't want to compute anything on the state. Simple as this. So let's see how this works. I have two buttons in here. I will click here. Great. A mutation was committed, and the getter was reevaluated, and then displayed a number 1. I will click again. Another mutation, another reevaluation of the state. I will use this one. Whoa. 2, 1. So I had 3 mutations that mutate the state. The number 3 is the single source of truth, the state that everyone knows about. And the 2 and the 1 are the self-contained state. Let's click it. Blah, blah, blah. 10. Don't forget, this getter will return a boolean. State count is higher than 10 or not. And I've made in here, let me see if I can show you. I have a show counter that returns, okay, it's higher than 10. If it's higher than 10, then it will hide the show counter. Let's see it. Bam, a show counter. Because we are watching the state, the single source of state that everyone knows. Everyone is writing to it, and everyone is listening to it. And if some action happens, then we know how to deal with that. So simple as this. Okay. Great. And to finish, I want to talk about Vue DevTools. Vue DevTools, it's a powerful plugin to the browser for Chrome or Firefox. It gives access to tons of information about the Vue instance, the 3 components. You can navigate them. You can see the state. We can see if they are rendered or not. Regarding Vuex, we can time travel in our app. We can imagine these are some mutations that I have. I can, just to see how the state was at some point in time, I can time travel to this mutation, and the application will re-render and show me how it was when that mutation was committed. And it is a lifesaver and a must-have for everyone that works with Vue or Vuex. So if you haven't tried it and work with Vue, you should. So just to show this in action, the Vue DevTools, I will show a little SPA that I've built to show this. Let me see if I can make it bigger. Oops, not too bigger. Okay. Everyone can see it? Okay. Nope. Okay. Right? And in this side, okay. This is an SPA just to consume some football data, and it's built with Vue Router that Filippo talked about, and Vuex. So the part of Vuex, I will run this again. Okay. It's loading the themes. This is the base state. So if I click in here and I go like Premier League, watch the mutations get fired. This was the mutations that we made to the state. This component, that component, this component, they're all looking to the state. And with this, as I said before, I can time travel, for instance, for this part of the application at this point. So if we want to debug something or see what is mutating the state. We can see it, for instance, at this point we don't have nothing. Well, I think we do, but it's not visible yet. We have the leagues, we have this league, it had nothing. So when this mutation gets fired, nothing yet, and this mutation, okay, we have something in the state. And this type of things make debugging your applications very, very, very fast and easy. So this is very cool to have in your browser. And it's it. So as I said, you can see the components as well. You can navigate on them. Okay. And you can see the data, you can see the bindings, you can see the props. So if you don't know it, you should know. Okay, I think that's it. I don't have nothing more to talk. I hope you enjoy it.